Hey students, we're going to talk about gas movement in this picture. So hopefully you guys got a chance to see a little bit about the gas movement during the computer simulation earlier this week. So there's two different types of gas movement. There's effusion and there's diffusion. In both cases, gases are going to move from an area of high concentration to an area of low concentration. With effusion though, that's where a gas escapes through a tiny hole. So let's say you puncture your tire and your tire starts going flat. That's because the air particles from inside the tire, where there's a high concentration, have effused through that puncture hole in your tire and escaped into the air. Okay, diffusion is where one gas moves through another gas. So let's say you're spraying perfume and you know that perfume smells. Well, that's the gas particles that are moving through the air. So that's going from the area of high concentration around where you sprayed the perfume to an area of lower concentration where there's no perfume initially, okay? Now when you look at these two pictures, this top picture here is going to represent which one, effusion or diffusion. This top picture represents diffusion because it shows a gas moving through another gas. Again, going from high concentration to low concentration. What about this bottom picture? Does that represent effusion or diffusion? That represents effusion because you can see that tiny hole there in the middle, and the gas particles are going to move through the hole. So, do gas particles all move at the same speed? No. And you should have seen that during the computer simulation. So if you see these two people on the swing, we have the adult and we have the baby. If you exert the same amount of force on both of them, and neither one is helping, so they're not using their legs and they're not kicking and helping them swing themselves, you're just pushing them with the same amount of force, which one's going to be able to move more? The baby's going to be able to move more because the baby is lighter. So remember that kinetic energy is based on mass and speed. So the masses are going to affect the speed if they're both exposed to the same amount of energy. So let's look at these two questions. First one, under the same temperature and pressure, which of these gases would diffuse the fastest? So if we're talking about speed and they're at the same temperature, now remember from the kinetic molecular theory, the temperature is a measure of the kinetic energy. So if they're at the same temperature, that means that they have the same amount of energy. So the one that's going to diffuse the fastest is going to be the lightest particle. So you want to look at their molar masses. So ozone is O3, has a molar mass of 48. Argon has a molar mass of just about 40. Methane is CH4, it has a molar mass of 16.05. And chlorine, remember chlorine is diatomic, so it has a molar mass of 70.9. So methane is going to diffuse the fastest because it has the smallest molar mass. All of the gases to the right are at 298 Kelvin. So remember, Kelvin is a measure of temperature. Which tube has gas particles with the highest kinetic energy? So looking at these particles here, we have helium, we have neon, we have argon, and we have krypton. So all noble gases. They're all at the same temperature. If they're all at the same temperature, that means they all have the same amount of kinetic energy. So their kinetic energy is the same. Now, if we unstopper these all at the same time, which one's going to diffuse the slowest? Remember, the speed at which the gases move, if they're at the same temperature, if they have the same kinetic energy, is going to be based on their molar masses. So the slowest one is going to be the heaviest one. So which of those four noble gases is the heaviest? It's going to be krypton. So krypton is going to diffuse the slowest. All right? So if you have any questions about gas movement or anything like that, just reach out and let me know.